GC, what's up? This is Coach Jay, Pre-Cal 12 / AP Stats. Hope you're enjoying yourself today. Hope you have power. Some of you may not be able to watch this because of the power issue. If that's the case, then I apologize for that. I know that we're going to be really flexible on trying to get the work done, trying to get the work in, and kind of going from there. If you are watching this, whether you're in Pre-Cal 12 or AP Stats, something to note is the quiz. We are going to have a little bit of time to review. And if you did not have power from Monday to Tuesday, I'd like for you to take the quiz on block day just so that it's not on you for too long. But if for some reason there's an issue with that, I will allow you to take it at a different time. But we'll talk more about that come block day. I'd like for you to try to get prepared for that. If you're not watching this, then it's probably one of those things where you may not get this information. But we'll just, again, be flexible with that. Some of you may be watching. If you've got questions, we're still going to post those questions. I did want to at least go over a couple of questions prior to the quiz for Pre-Cal 12. And then come AP Stat we'll do at about 10 o'clock here, okay? And we'll do it on the same podcast. So if you're watching this, we'll do it both. The first half hour will be Pre-Cal 12. The second half will be AP Stat. And we'll go from there. Okay, let's get underway. I've got a little music in the background. Hopefully that doesn't mess things up here. Just kind of some chill music, you know, trying to get it rolling. Hope you're enjoying y'all's days off, and hope you're staying safe is the big part there. Okay, let me get this. Okay, awesome. So some of you are already starting there, and I see that. Great, see Matthew there. A little early there, Matthew, but appreciate you for showing up. I'm just gonna do a couple Pre-Cal 12. If I don't see anybody on here other than you, we'll go into more AP Stat, and we'll hit some of those homework problems, right, dude? Okay, so as we get started, we are going to hit on just a couple of questions here. I was going to do the first one about right here, and then this would be more of the second one that we'll hit. So let's do this. Let's talk about the cosecant graph. First off, remember anytime we do a cosecant graph, we need to first figure out what the sine graph is, right? So let's try to do the same thing, except now, remember, we're going to find the sine first. And to find the sine, we're going to do the three parts here, the amplitude, the period, and the phase shift, okay? Now, the amplitude, it has the value that's in front of cosecant, and that value will be 1. So we're just going to put 1 there for the amplitude. Now, the period has a measurement of 2 pi over b, okay? So we have 2 pi over b, where b would be 2 pi. Okay, so we got 2 pi here, because it's the value with the x. And remember too, when I do phase shift, we do c over b. Well, because there is no c here, this -1 is on the outside of that. It has no effect on the phase shift because it would need to be in parentheses. Therefore, there is no c, so we have 0 over the value of b, and so 0 over anything, or 0 over 2 pi here, would just give me a value of 0, okay? So we have a phase shift of 0, and when I go up to my period will have a distance of 1, okay? So I'm going to start at my beginning, so this is my 0 here, okay? And I'm going to go total distance. Remember, the period length means that I'm going to go up, down, and back up again for sine, right? Where this is the beginning, the middle, and the end, and the quarter points would be here and here, okay? So I'm going to just kind of measure this out. We'll go to 1, about right in here. It's nice because when I do this, I can kind of see that between 0 and 1, it'd be 1/2. And between 0 and 1/2, I'd be about 1/4, okay? So right now we're adding 1/4, so it'd be 1/4, 2/4, and so the next one would be 3/4. Some of you could just see it there. Okay. So I've got that there. The next question is okay, so if I'm graphing sine, we've got the first part over here. How do I graph it? Well, remember, we're going to go through the 0, We're going to hit the top point over here at 1/4. Okay. We're going to go through 1/2, so it's going to come down through 1/2. Hit the bottom at 3/4. Okay. And then go up to 1. Okay. Sorry about that. My mouse right here is what I'm using. So my apology on that there. But then we just follow the same pattern. So whatever scale I did over here, I'm going to do the same scale over on this side. If my period was 1 and I ended at 1, if I added one more, I'd get 2. And if I added a half between 1 and 2, I would have 3/2, or 1.5, you could say as well. And again, I'll take a decimal on this, except when I have a pi, we would want a fraction. Okay, so I'm just going to keep it as that here. And there you are. There's my 2 periods. Okay, period 1 from 0 to 1, and from 1 to 2. That's the second period that's there. So I've got my 2 periods. I graph the sign. Let's talk about amplitude real quick, because this -1 kind of comes into play. Well, since the amplitude's 1 and -1, I start with that. But because of this vertical shift on this outside right here, that vertical shift impacts the amplitude and changes this 1. If I go down 1, it wouldn't be 1 anymore. It'd be like 0, right? And if I go down from -1, it won't be -1 anymore. It would be -2. Notice some of you tried to actually like redraw this, like going down 1. And look, here's the thing. As long as I label my highest and lowest, my graph doesn't change. What happens is now this is now my new like 0. This would be like my x-axis up here. And this new horizontal would be a value of 1, where this is or -1, I'm sorry. And where this would be a value of -2. So as long as you label appropriately, we're good to go. Another thing to remember is this -1. A lot of times we call that the center line. Okay, it's the line that kind of falls in between the sine graph. And so again, that would be sufficient. Now, in finishing up, we got to do now the cosecant. Okay, so wherever it hits the x-axis, that's where we're going to do our vertical asymptote there. Just one there. Good and good. Okay, so if it's a parabola, or it's like a slope there kind of going up, like a maximum, we have a little parabola going up and a minimum of a value going down. Same thing up here, value going up, and this will be a value going up. This one going to be a value going down. So that's sufficient right there. I got my vertical asymptotes with my parabolas. The green part is the cosecant graph, but I have to draw the sine to get to the cosecant graph that's there. Okay, excellent. Let's see how many viewers we've got going on right now. All right, we got 2 viewers there. So if that is you, I know one is AP Stats. So if that is you and you need some more questions, please throw those out there, okay? And we'll rock and roll from there. Okay. Now with this one, okay, this 2 here, this right here is our tangent, right? So we know 2 would be our amplitude. I'm not going to use the top part because, again, remember with tangent and cotangent, we don't really need period and phase shift. We just need our asymptotes, right? There I go again. I tell you what, man, that's just habit. It's just habit. It's one of those things I just write down. All right, so we got our amplitude. And now for our asymptotes, we've got 2x minus pi. And what we're going to do is we're going to take 2x minus pi. And what we'll do is set it equal to 2 values. Remember with cotangent, it'd be 0 and pi, we set it equal to. But with tangent, we set it equal to pi over 2 and negative pi over 2. Now, I'll tell you, this is a really good one. Okay, really good one. So let's see if we can solve for it. So we're going to add pi here. Okay, what I do to one side, I do to the other. But I can't add these together yet until I get a common denominator. So that's why I'm going to put 2 on top and bottom of that pi. So when I add these 2 together, my value would be now 3 pi over 2, okay? So I'm going to kind of erase this. So this would be equal to 3 pi. This would cancel, right? This would be 3 pi over 2. Now, in order to get rid of this 1/2, I'm going to multiply by 1/2 here because that's what was by itself. So I've multiplied by 1/2. So my first asymptote is going to be at 3 pi over 4. Okay, so I'm going to hold on to that. Now over here, I do the same thing. I'm going to add pi to both sides, but I've got to do a common denominator. So I have 2 pi over 2. Okay, cancel this out here. And 2 pi over 2 minus pi over 2, we get just positive pi over 2. Okay, and because we're trying to use a common denominator. So we got pi over 2 here. I multiply by 1/2 on both sides. Whoop, just like that. And 1/2 times pi over 2 gets me pi over 4. So my two asymptotes are at pi over 4 and 3 pi over 4. And my amplitude is 2. I will tell you this is a really good one for the quiz, just telling you. What we'll do is we'll put this as 0, okay? And we'll say every 2 marks is going to be a pi over 4. So we'll say this is pi over 4. This one will be 2 pi over 4. If we reduced it, it would be pi over 2, right? Coming there. There we are. And if I did it one more time, this would be 3 pi over 4. And the last one would be a positive pi. Okay. So in doing my asymptotes, I'm going to put one at pi over 4. Perfect. And one at 3 pi over 4. Again, these are my asymptotes. Remember, the tangent's undefined at certain spots that on our unit circle, and that's where it corresponds to these asymptotes. It's not continuous like a sine or cosine graph. That's why we got to be careful. So remember, in the middle, we have it here. We don't need to find our quarter points on this one. Only tangent and cotangent, you don't have to. Okay. And from the middle, we're going to, for tangent, remember, you're going to rise the right, fall to the left when it's positive, and then it flip-flops. It'll look like a cotangent graph. It'll look like this if negative, okay? It's negative here, right? That's confusing. I'm sorry. The dotted line would be negative, and the solid line would be positive. So as I rise to the right, remember at the quarter points, it's going to go up to the amplitude, and as it falls to the left, it'll go down to from that side. So we've got a graph that looks like this. That's our tangent graph. Remember that from 3 pi over 4 to pi, if I added one more pi over 4 here, this would be like 5 pi over 4. You could actually count it, right? Because this would be the 5th tick mark. And remember, each one would be pi over 4. So if added, we'd produce a value of 5 pi over 4. And so what we'll do now, from the middle, same thing. The quarter points it'll go up to right here and here. Have it come down and have it go up. Now, what if I did ask, hey, what's the period length? Well, remember, the period length is what is between the asymptotes here to here. So from pi over 4 to 3 pi over 4, I could subtract the highest minus the lowest. So 3 pi over 4 minus pi over 4. And my period length would actually be equal to pi over 2, or 2 pi over 4, which reduced to be pi over 2. So just a heads up there, would not ask for the phase shift because that's built in. And really, I don't need to find the period. But what it does is actually the equation for the period is, instead of 2 pi over b, it's pi over b. So it's like half of what the traditional one is. That's how we get pi over 2. But I like to graph it first and then look and see, oh, what's the period? And based upon the amplitude and asymptotes, that will be given to me there, okay? All right. I did, actually, I'll keep that there for just a second. Awesome. Okay. Yeah, so the quiz tomorrow, I'm gonna give you some information on that in terms of we're gonna review before that tomorrow. I'm assuming that we should be good to go. We've been reviewing over a lot of these trig graphs for a while now. I think we had about 3 days or so where we reviewed, went over. I think we started last Tuesday where we did sine and cosine. We did a block day. We did tangent and cosecant and secant. We've done all of them. And so Monday was supposed to be kind of like a review day. And then today we were supposed to take the quiz. But obviously that's changed a little bit. But with the podcast, I think there's a total of 4 podcasts where we've hit over trig graphs. So I'm going to assume that if you've watched these, that you're ready to go for that quiz come block day. Now, if it's one of those things where some people say, well, coach, I can't do that because I've got, I didn't have power or Wi-Fi or whatever. I'm going to let those people kind of make that call on that. But for me, I'm going to assume that we're good to go on that. So if there's some questions on that, let me know. But we're going to try to do that quiz there. Okay. Yeah, Michaela. So remember that, and really, if you just remember the fact that pi over b is with tangent and cotangent, that's good. For me, I don't even look and see that. I don't even really look at this. I just say, hey, what's the distance between one and the other? Now you could actually find this, but remember it is built in to the asymptotes that when you find the asymptotes, the distance from one to the other will give you what that period length is. And I don't think I even asked for that on the quiz. All I ask for is the amplitude and the asymptotes, graph it, and just make sure you do 2 periods on that, okay? I think what I'll do is I'll post the formulas for all of this stuff on the board. So all the stuff for sine, cosine, and I'll try to put reminders up on the board. That way, I try to set you all up for success. This is just a quiz again, and so I'm not trying to nail you all on this. I'm just trying to make sure that we're up to date with what's going on and make sure that we're all good. So again, sine, cosine, secant, cosecant, cotangent, and tangent are all the 6 graphs that you'll need to be ready to go on there, okay? Hopefully that makes sense on that. Okay, so with about 12 minutes left, I'd like to see here. This may or may not work. Let's see. We're going to try to see here. Yeah, it keeps trying to do that. Okay. What I'm going to do here is I'd like to just kind of put a couple of extras of these on. So if you're like, man, I'm struggling on some of the, let's see here. If some of you are struggling on 4.7a from the podcast that I had sent, by the way, you can keep throwing questions out there. I've got about 12 minutes left with this group with Pre-Cal 12. Let's take a look at these 4. These were just practice off of the podcast here. And so I want to just kind of go through them with you and just see if there are any questions. We could kind of address that and go from there, okay? Okay, so I'd like to get a unit circle here. I want to get a unit circle. Try to just... Perfect. Okay. So what I'd like to do is just kind of use this unit circle to help with some of these problems that are here. We'll go through maybe 4 of these. These are off the homework. So if you're like, man, where are these from? These are off the 4.7a homework, which will be due on Thursday at midnight. Okay. And we'll talk more about that in class, but this is just going to set us up for what we'll do on block day. Remember that when we have the inverses, right? We're talking inverses now. That the inverse in the -1 represents this. You could also say arc cosine, right? Or cosine the negative first. I'm just doing a shorthand because I'm trying to do this all by hand here without the pad. So it might look a little messy, but we'll be good. So we've got, these are the ranges, right? Where nothing's in the 3rd quadrant. And when we talk about cosine, it could be from 0 to pi in the 1st or 2nd. And sine and tangent are from pi over 2 to negative pi over 2. And so let's take a look at a couple and see if we can figure this out. So the sine inverse, again, arc tan is tan inverse. Arc cosine is cosine inverse. Arc sine is sine inverse, okay? All the same thing. This says what or where is sine inverse square root of 3 over 2. So what I've got to do is I've got to see from negative pi over 2 to, oh, really, this is pi over 2 to negative pi over 2. Where is sine square root of 3 over 2? And so I could kind of see that, right? Where is the y square root of 3 over 2? Well, this is negative down here, right? So what we want to do is find where it's positive, and we could see that the value of square root of 3 over 2 is here. Therefore, where is sine square root of 3 over 2 in my range? It would be pi over 3, okay? Now you'll notice that there's another spot over here. It would be at 2 pi over 3, but notice it's outside of the range of sine inverse, right? So if it was, you can't find it over here. It only can be between the first to fourth quadrant, okay? So just be leery of that, but this is the correct answer on this one. For our cosine of 0, we're really finding where is x 0, and it's got to be between 0 to pi, right? Because it's got to be between either the first to this or to the second quadrant. So any values from 0 to pi could be our answer. So to kind of help us out here, we're going to look and see where is the x value 0. Where's the x value 0? So as I look at the x value, and I notice that the cosine inverse will be 0 at a value of pi over 2. Again, we're looking for the angle in terms of radians, in terms of pi, but we've got to make sure that it's within our range, and that's what we're looking at here. So pi over 2 would be our answer. If you're seeing this for the first time, I would highly recommend going to the other podcast, which would be right above me, right here. You can see it right above. And check that out because that goes in a little bit more detail than what I'm doing now. This is more of a review, okay? Now this one, let's go to this one. Arc sine, again, is the same as sine inverse, okay? It's the it's its nickname, okay? Arc sine there. Where is arc sine 1/2? Or better yet, where's the y going to be 1/2? And so again, I'm looking from anywhere in the first to fourth quadrant. From pi over 2 to negative pi over 2, and I look to see where's y 1/2. That answer would be at pi over 6, okay? So I'll put that down. That's where my answer would be. Now, the last one I want to do is this one. This one's a little bit tricky, okay? I want to erase a little bit of this just to kind of show you. First off, we know that since it's tan inverse, we're really focusing on the first and fourth quadrant. That means we can't be over here, okay? Remember with tangent, if I did tangent, that means it's y over x, correct? Okay, y over x. And what I'd like to do is just show you what the y over x is. So over here, this would be square root of 3 over 3. If I did y over x, this would be 1, and this would be square root of 3. Okay, so it's got to be in one of these 4. That means down here, if I did it, since it's kind of the same as the 30-degree angle, just now it's negative 30, right? Or negative pi over 6. We'd have this as negative square root of 3 over 3. This would be negative 1. And then this would be negative square root of 3. Okay? So here's our values from pi over 2 to negative pi over 2. And this would be in the middle. This would be y over x would be 0 over 1, which would be 0. So these are the tangents that we could have for our tan inverse, right? So those are the values corresponding to the angle. So again, arctan means we're finding the angle. But this time it gives us that it's a negative square root of 3. The problem is that if I did negative square root of 3, you know that it would be down here, and a lot of people on the test, I'm telling you, a lot of people will put 5 pi over 3. The problem with 5 pi over 3 is in order to get there, I've got to start at 0 and go outside of my range to get inside, right? So I'm trespassing, right? I'm trespassing over here. When I used to drive, there would be times where if I was headed to Michigan, this is my destination, the quickest way might seem like going through Ohio, but because I don't like Ohio State, we would find another way, right? Same thing, this would be trespassing because we're going outside of our range, but we can't go over this way, right? It's illegal to go this way. So because of that, it's not 5 pi over 3. We've got to start from 0, but this is where we can go down to any values between 0 and negative pi over 2, right? So in doing so, can't do this, right? Right here. We've got to go backwards. And so 5 pi over 3 is coterminal to a value, which is, again, what corresponds to this? Same exact coterminal angle would be negative pi over 3. Now, some of you could see that and say, well, since it's 3, it's got to be negative pi over 3, right? Yeah, which is true. You could also subtract 2 pi from this, which is coterminal, right? Get a common denominator of 3. what I do at the bottom, I multiply by the top to get 6. And when I subtract, I get negative pi over 3 as my answer. Okay. Hey, I hope that made sense a little bit. I just wanted to review that just a little bit with y'all as we went and go from there. Pre-Cal 12, thank you all for showing up. Now I'm going to transition to AP Stats. So if you are watching with AP Stats right now, I'm going to throw something up here on the board on this. Erase this. Let me throw this. Where's the 4.2? No, not 4.2. I'm sorry. You get this one here. 4 point. I'm gonna get 3.2. And so let me do this. Let me throw this up here just in case. So right now we've got, if you're watching this, AP Stats will start in 2 minutes. 2 minutes right now. If you are watching this, we'll start in 2 minutes. So give me just a little bit to transition. Throw up questions. If you've got questions on the homework, I'm actually pulling those up right now. Feel free. 3.1, we'll address those too. I think we went through a lot of the multiple choice yesterday, which was on 3.2a, I believe. I think it's 3.2a that we did that. So what we'll do is we'll go through specific questions from 3.1a to 3.1b. If you've got other questions on the Monopoly thing, we will address that as well. So again, we'll just hold up just a second. Let me get this up, and then we'll go from there. So if you've got questions, throw them up there, and we'll go from there. So hold on just a bit. We'll go. And if you get, as you do this, as you take this out, if you have any other questions in terms of, Coach, hey, what ones would you recommend to go over, anything of that nature, just again, throw it out there, and we'll do those in just a bit. If you could give me just a little bit of time, I'm trying to take these snapshots real quick just to make sure. I'll throw these up here. Actually, I think I've got these, but let me just check. Now that I think about it, I think I've got them. Let me go back and just check and see. But I'm going to get those up in just a bit. Again, Pre-Cal 12, thank you for showing up. AP Stats, if you've got questions, throw them out there. We'll begin in just a bit. These are different, so I'm going to keep those there. Again, I'm throwing these questions up here, but if you did have any, it just shut down on me. Let me just shut down. Sorry about that. Something's wrong. It's coming back up. We'll get that pulled up back up for us here. pull these back up. Okay, so again, questions on this. If you got questions on a specific homework question, I think I'm trying to get almost all of them pulled up, so at least have them on here. And that way we could go over any ones you want. Again, please throw the questions out there. We'll address those. Probably going to go to the more of the later ones, just because of the fact that those were some of the more new topics that we did yesterday, and so I might kind of work backwards a little bit, especially the correlation part. But again, if you've got other questions, let's say you've got ones and you're like, man, I just don't get this topic or whatever. Any question is available there, and so on and so forth. One of the things too is, as I talk about this, is I will encourage you. It is there will be a quiz on block day. I'm going to provide some review time though. I'm not going to just leave y'all hanging on that. So just a heads up there. Okay. Okay. Let's see here. I think I have a question on the site that I want to address. Yes. Okay. Let's talk about some questions here. Do we need to know the difference between an extreme data point and outliers? Okay. Extrapolation. I know what you're talking about. Okay, great question. Let me show you the difference between the two, just in case, because it could be a question either on the quiz or something of that nature. Let's say we have our X, whatever context you want, right? And let's say that we have Y, again, whatever context you want. Remember, X is the explanatory. It explains the response of Y. And let's say we have this positive, we'll say moderately strong, positive linear scatter plot here, okay? All right. What we're going to do is let's talk about an outlier. First off, here is the data, right? Here's the data that's represented. An outlier would be within this set. An outlier would be something that's like out here, okay? So it's within the data range, right? It's within the range, but it's like, man, it's way out here. Remember our GPA? We talked about our GPA explaining our ACT. An example of this would be, an outlier would be, let's say you have a high GPA. Let's say you have a 4.0. But let's say you just, man, the ACT or SAT just struggles. It's a struggle there. And so because of that, you got much lower than what would be predicted, right, within this scatter plot. So if you had this, again, we'll say there's a line of best fit. You put your GPA in and your predicted value, right, your ACT hat, if I had a GPA of 4.0, let's say it was supposed to be up here, but it didn't. You got something way lower, right? And so this ACT, though it was predicted, the reality is that you got something like right here. This right here would be called an outlier, okay? It's an outlier. Now, extrapolation, which we talked about yesterday, is a value that is outside of my range. So we use the example of, let's say I have a GPA of a 5.0, and I know I'm going into this problem, sorry. We'll kind of move this for a second. Let's say I had a GPA of a 5.0, and let's say that based upon that, we got a score that was here, right? Or that we got a GPA that's here. So, and I say, okay, what is my predicted value of my ACT score if my GPA is 5.0? The reason why that's extrapolation is because that guess, or that the explanatory of 5, when I plug that into the formula within my regression line to predict a value of my ACT, I can't predict my ACT value because of the fact that it's way outside of my range of my scatter plot. So the outlier is a point where I have the X and I have the Y. I have the explanatory and the response. The extrapolation is I have my explanatory and I'm trying to predict what my response will be by plugging it into my regression line, but I can't because this value is way outside of my range of my scatter plot, okay? I hope that makes sense there. If not, let me know, and we'll walk through that there, okay? Does that make sense? Also, am I frozen here? hoping I'm not. Hopefully not there. Okay, good. Yeah, I don't think I am. I just wanted to make sure. Okay, so hopefully, again, that makes sense there. Perfect. Okay. Are there any homework problems that y'all would want here? I know as I look at some here, I've got like 6 viewers on this, which I appreciate. Any problems specifically that you want? What I'll do is I'll keep this off to the side right now, and I'll just start on some homework problems. And if there are some questions, number 14, perfect. Let's do number 14. 14. Okay, I think this one's it. If it's a little bit off, let me know. Page 159. I think that's it. Let me make sure. This is the one I've got. And we will do this one. I believe this again is it. Okay. Number 14. Yeah. Okay. So does social rejection hurt? Okay. So it says, we often describe our emotional reaction to social rejection as pain, which is kind of interesting. And if it does, we really do experience social and physical pain in similar ways. Psychologists first included and deliberately excluded individuals from a social activity while they measured changes in brain. Okay. All right. So it goes into the details. 13 subjects talked about social distress. So values greater than 1 show the degree of a distress caused by exclusion. Brain activity is the change in activity in a region of the brain that is activated by physical pain. Okay, so this provides context here. Let's talk about the scatter plot, all right? It says make a scatter plot to display the relationship between social distress and brain activity. So what we're trying to do is say, okay, does social distress explain my brain activity? Now, you're going to actually create a scatter plot. What you want to do is, you have the subjects here, but the subjects, the numbers that is not my X and Y. It just shows which one is which. So this is subject 1. We have social distress. And we know that the X would be my explanatory, and I would actually put a label of social distress there, okay? And I'll just put SD because right now I'm writing with my hand, okay? And my Y would be my brain activity. So I'll put my BA here. Now, how you do the scale of this is completely up to you. I know for my brain activity, you'll notice that this is more, the lowest value would be like 0.01, negative 0.01. So what we want to do here is try to create, we'll say zeros like right here, okay? And what we'll say is that right here on the bottom, this would be like negative, we'll do negative 0.01, 2, 3, 4, 5. Yeah, I think 1, 2, 3. Let's do, let's say it goes down by negative 0.03. Is that right? Let's go negative 0.03. And if I went down further, we'll do this as negative 0.06, okay? And again, yours could be different on this, but again, it's kind of up to you. So as long as you have it balanced. This would be, let's put this as 0.03. This would be 0.06. Again, I'm sorry for my, and then this is 0.09, and then this is one's 0.12, okay? So again, my apology on this. This is negative 0.06, 0.03, 0, 0.03, 0.06, 0.12, okay? So let's take a look at this. The SD is the social distress, and these values go anywhere from 0, 1, 2, and 3. So let's say that each of these would be like 0.5. So 0.5, this would be 1, this would be 1.5. And again, I'm sorry, I'm trying to do this by hand, which makes it really difficult. 2, 2.5, 3, and 3.5. So once I kind of get all of my values in a possible range, maybe 4 right here just in case, what we're going to do is just see what they correspond to. So if we have X, X explains what my brain activity would be. So remember 1.26, let's see, make sure. Okay, fill out a questionnaire. Okay, so values greater than 1 show the degree of distress caused by exclusion. So this was, again, greater than 1. This is with exclusion. Brain activity is the change in activity in a region of brain that is activated by physical. So positive values show more pain. So this would be like kind of more pain, right? So this increased pain. This is more on the decrease of pain that's there. It doesn't really go into what this is, but that's kind of the idea, okay? That means we don't have less pain. That just means, or this doesn't mean that we have negative pain. This just means that we have less than the 0.124. Like this would be a lot, okay? So the social distress of 1.26, we're going to put a dot at negative 0.05. So that's about right there. The next one, 1.85. And by the way, you could do this on your calculator, but I would like for you just to kind of get a little bit there. So we got one here, 1.85, and it's not going to be perfect, but that's okay. 1.1 would be negative 0.02. So it'd be a little bit higher, about right there. 2.5 and negative 0.07. Negative 0.07, good. 2.17 and same one, so about right in there. 2.67 right here, and that would be 0.01. So you kind of see the idea. I'm just trying to create this dot plot as best as I can, especially on this. 0.02, so right there. 2.18 would be here. 0.025. Perfect. 2.58 and right here, 2.58, 27, 0.027. So I think it's about right in here. I'm just gonna there, 2.75 and 0.033. Kind of see it go up here, and 2.75 and 0.064. 3.33, 0.077. This should be 9, so it should be about right there. My fault there. I know it's kind of ratchet there. 3.6, 0.124. Okay, so as I look at this data, if I were to draw a line of best fit, this line of best fit would follow maybe a pattern, probably a little lower than that. But that would be a good regression line for this. Now, it doesn't say to find what the regression line is, though I could put this into L1, L2, go to stat, calculate, go to linear AX plus B, and find that regression line, right? I could even plug this in my calculator, but it doesn't say that. It says describe what you see. And so in context, I would say when X, let me put this here, so I can kind of change this up. White would not be good on white. That might not be a good idea. There we go. When, try to throw that out there. Perfect. When social, when, let's say, how about when explaining the way social distress impact, how about that? This is why we do this, talk it through. When explaining the impact social distress has on the response of brain activity, we find, and when we describe it, right, we need to describe it within DOS, right? We want to describe DOS here. Okay, so find that the graph is a positive, I would say fairly strong, right? Is a strong linear, strong positive. Let's do that, positive linear relationship. When I'm just making sure I read this right. This takes me a while to do. When explaining the impact social distress has on our responsive brain, we find that the graph has a strong positive linear relationship with no outliers. And then I would say this means that as social distress increases, brain activity and I would say brain activity experiences higher amounts of pain. Something along those lines would be perfect there. Again, maybe not, and I'm sure you probably could utilize that, but that's a really good context right there in nailing that on that one. So again, if you do have more questions, I know it took me a bit. You saw me battle with it, just like you might battle with it on a quiz or a test. But that would be good because I did DOFs here, and I went right into context of what does that mean? What does DOFs mean? And so we could kind of have a good idea of what that would mean by what we said there. Okay. All right. Do you have any other questions on that? I'll keep going through. I'll do number 15, but throw another question out there. That would be awesome if you have any other questions on this one. This one says match each of the following scatter plots to the R below. This is very important for the quiz because I have a lot of questions on R, this correlation idea. Remember, -1, more of a cluster form, will approach 0, right? A positive linear relationship is one that has a positive slope. One that has a negative slope, and it's hard to see because I cut that off, but this would have more of a negative slope. And so let's just take a look at it. Okay, let's take a look at it and see. So let's go to the first one here. Let's do, I think 3, 6, right? So 2, 4, 6. Okay, so the best we know how, let's try to nail this out. Okay, so the line of best fit or the regression line would be something along those lines. Those are pretty tight dots. And so because it's positive, it's going to approach more of a value of 1. And so I would say that R equals 0.9 because it's positive. That would be more of what that one would be here. Okay. This is more of a cluster right here, a cluster. I don't know if that's supposed to be a value there. I would say that's a tough one. I would say this one approaches 0 on this. I'm actually going to look in the back of the book because I'm thinking that I got cut off on one of those. But as I look at this one, I would sense that this one's approaching more of 0 here. So let's go to 2.15 on that. 3.15, I'm sorry. All right, and B, yeah, this is supposed to be 0 up here. I was like, man, that does look like 0. All right, so yeah, that's supposed to be 0. So this R equals 0 would actually be down here. I was like, I couldn't see it. I was like, what is going on? But yeah, that's what that would be there. Now with these ones, you'll notice that it's still kind of a cluster form, but it still does follow a rough pattern. So I would say on this one, it's not as tight as here. However, there are still, you could still see kind of a good pattern. It's a little bit more spread out. So because it's positive, what I would say is that the R equals 0.7 would be the one that I would put for this one. Okay. Now for on the D part, you'll see that this one here is kind of this way. This is more spread out than what C is, but it is still in a negative form. So I would say it's not negative 0.7 because it's more spread out than the positive 0.7. I would say that this is negative 0.3. Remember that when I talk about the correlation, the closer it gets to 0, the more of a cluster form this would be. So I would say that D would be more of negative 0.3 on that one. And then finally, this one down here, do this one in green. This is, you'll see it better on your online homework here. But this is, again, a negative relationship and pretty strong. So I would say strong negative linear relationship. So because it's a strong negative, we're going to say that this one, very similar to number 1, the only difference is it's negative. We'll say that this negative 0.9 would follow the format of E there a little bit better. Okay. Again, just trying to get a good idea on that. Being familiar, you don't have to know exactly like, oh, this is 0.9. But when I look at a picture, you should be able to kind of have a better idea of oh, yeah, this is what this is, and so on and so forth. Okay. All right. Okay, I want to make sure that as I go down that there are no other questions. I still have about 9 more minutes, so if you do have another question, let me know. So let's keep going. Let's do number like 17. You would do number 16 too. Just remember to look at what numbers are there. This one's number 17 says each of the following statements contains an error. Explain what's wrong in each case. So let's talk about this here. Yeah, let's do this. There's a high correlation between the gender of American workers and their income. All right. Consider each of the following, or let's see, each of the following statements contains an error. Explain what's wrong in each case. Okay. There's a high correlation between the gender of American workers and their income. Okay. The problem with this is the fact that what is gender? Gender is categorical, right? There's no quantitative measure with gender. But income, when I talk about income, that is quantitative. But in order to find correlation, correlation is R, right? We have to have two. We have to have two quantitative measures. So I would say something with A. I would say in order to predict correlation, we must have two quantitative values, or yeah, two quantitative values. And I would even put with an explanatory and response variable. Okay, that would be a good A answer right there. The next one says we found a high correlation, R equals 1.09 between students' ratings of faculty teachers. That's quantitative. We're good. And ratings made by other faculty members. Sorry. This is also quantitative. So we're good there. What is the problem here? I want you to just yell it in your house. Go ahead. Nicely done. R cannot be greater than 1, right? Remember, if I have a perfect line in a scatter plot where X is over here and Y is over here, the highest value it can have is 1. If every dot went through this regression line, that would have a value. In this case, it's positive 1 because it's a positive relationship. So the highest value you can get is 1. So saying something about the fact that you can't have an R or a correlation that is greater than 1.09, I would find a different statistician on that to find correlation there. Okay. All right. The next one, the correlation between planting rates and yield of corn was found to be 0.23. Okay. First of all, between planting rates, that's quantitative, and yield of corn, that's quantitative. So we're good to go there. We got the correlation started there. The next one says it was found to be R equals 0.23 bushels. Well, remember, I think we talked about this in the notes, that when we talk about correlation, okay, if I increase planting rates, right, this is my explanatory. As I increase planting rates, will my yield of corn increase? Well, if I plant more, my yield of corn would probably be more, right? So maybe this correlation would look like this, but you would see that it could be in the general vicinity within my regression of a positive relationship. But here's the thing. First of all, 0.25, that's a weak linear relationship, right? Or a weak positive linear relationship. But the problem is the fact that when we use correlation cannot have a label, right? It can't have, what did I call that? It can't have a, like, I can't say it's bushels or centimeters. Correlation is just simply the correlation between X and Y. They're explanatory to the response. So correlation, I can't use bushels. I can't use a label when expressing correlation. So that's what C would be on that one, okay? All right. Again, if you have any other questions at all, throw those out there. 21, I'm just going to keep going through some of these. Oh, yeah, this right here would be a good one to kind of look at. I'll kind of look at this one. Consider each of the following relationship: the heights of fathers and the heights of their adult sons. So I think that as the fathers increased, the heights of the sons would increase too, right? Because that'd be a positive linear correlation. What about the heights of the husbands and the heights of their wives? Well, I improve. Hold on. First of all, I want to just look in the camera here. Did someone mean to do this? Because just because my wife's taller doesn't mean that that I don't need to be taller than her. I'm securing that, right? Securing that. So I don't know why I needed to just say that, but maybe that's true. Maybe that's not. I would say the correlation between the heights of the fathers and the heights of the adult sons has a higher correlation than the second one. And then the third one is the heights of women at age 4 and their heights at age 18. Again, that'd probably be a pretty strong one there. I would say the weakest one is the number 2, the second one. That's the weakest one. The heights of the fathers and the heights of their adult sons. I would say that has a pretty good correlation to it. The heights of women at age 4 and the heights at age 18. Man, I'm trying to think. You probably could provide a better understanding or better explanation on this one than I could. I would say the second one's definitely the weakest. The first one, I would say the first one is second place, okay? The reason why is, think about your mom, right? You also have your mom's traits as well. My mom's like 5'1", right? My dad was like 5'10", and I obviously was affected by my mom's height. So maybe that there is a correlation there, but I think that it wouldn't be as weak. So I would say from the highest correlation would be the third one, because what you would be at age 4 to 18 would probably be really tight in terms of that, where I'm at age 4, probably the age 18, even though I would increase, that would follow a pretty tight pattern. So I would say the strongest would be 3. The next highest correlation would be the number 1, and the weakest would be 2. Now, again, that's me. That's where I'm at. But maybe you could provide a better explanation of that one on there. But yeah, so that's what I would put on that one. But again, as you explain that, you could explain your reasoning by putting things in context, and just kind of like what I said to you, the fact that husbands and wives, that's a weak correlation, because that may not necessarily be the case, right? You may marry small. Me, I married taller, so I could have taller kids. Some of you might decide to do something different. And because the fact that it was very hard to find any girl that was shorter than me. And no diss on that. Okay. All right, no boost right there. Okay, number 21. Are hot dogs that are high in calories, this will be our last one, also high in salt? Figure below shows a scatter plot in 17 brands of here. So here's the hot dogs that are high in calories, right? So here's this, right? And here, okay. So is it true that they are high in calories, also high in salt? Well, as we look at it right here, I would say absolutely yes. And providing context is because this graph, this linear regression line, displays a graph that as the calories or the explanatory increases, the sodium or the response to that increases as well. And so in doing so, we show that there is a correlation where a strong positive linear relationship between sodium or calorie contents and explaining the response of sodium increase. And so I know that was I was all over the place, but that's kind of how I would do that on that one there. Okay. Thank you all for showing up. I had 3 viewers. I know bumped up to 6 there. Hopefully that was helpful for you in doing the homework. Again, whether you're in Pre-Cal 12 or AP Stats, we will have a quiz on block day. If for some reason there's been an issue at your house, or there's stuff going on, obviously I'm going to have grace in that. I'm going to have a little bit of a review beforehand, hopefully to help explain and kind of navigate where we're headed. So just a heads up on that. But please watch the podcast if you're able to, and that way we can hop right into our stuff come block day, okay? Care about y'all. Love y'all. Stay safe, and we will see you tomorrow or Thursday. See y'all. Bye.